Okay, we're going to do how to do single radicals and mixed radicals. So we're going to be able to interchange them with each other. Okay, so root 7 times root 3. What are the rules on how to make that into a single radical? You would just make it a root 21. So root 6 times root 11 is the same as root 66. Okay, root 7 times root 9 would be root 63. Okay, you get the idea? Here's another one that's kind of tricky. So root 5 times root 5. Okay, if we follow the rules before, it's just root 25. But we know that's just 5, the whole number 5. Okay, so you can see that this is us taking root 5 and squaring it, because it gets repeated twice, and then it ends up canceling each other. So root 7 times root 7 should just end up being a whole number 7. Okay, if I do something like this, where I'd like 6 root 5 times 2 root 3, so this part you would have to treat your whole numbers or your coefficients separately than your radical pieces, where you'd have 12 as a coefficient, root 15 as a radical. So here you have to have your coefficients. We have a coefficient of 8 and radical parts, root 18. Okay, so let's break down roots. So root 45, think about multiples of 45, and we're trying to get perfect squares. So you remember your perfect squares: 1, 4, 9, 16, 25, 36, 49, etc. So does 45 divide by any of those numbers? 9. So root 9 times root 5 is what root 45 can also be written as, right? So right here, I'm just doing the opposite of what I did here. So here I had 2 separate roots and times them to a single. Here I have a single and I'm timesing them into 2 separate. And then I'm simplifying it because root 9 is a whole number 3. Okay, so root 27. So can I use any of these numbers? I can divide root 9, root 3, because root 3 times 9 is 27. Root 9 is a whole number 3 with a radical 3. Root 12 can break down. So out of those numbers, I can divide 12 by 4. So root 4 times root 3, and then root 4 is 2. Root 50, so root 50 can be divided by 25. Root 25, root 2. Root 25 is whole number 5, and then 5 root 2. And root 48, okay, so I can divide 48 by 4, but it's not going to result in my answer because I can also divide it by 16. So I would like to take the largest one. If you divided it by 4, you would have to do a second breakdown. Okay, so it's not going to be wrong, but then you'd have to break it down twice. So try to take the larger of these that can divide by. 16 times 3 is 48. And then this is a whole number 4, so 4 root 3. So let me just show you if you had done 4 times 12, okay, so that's 2 root 12, but then root 12 can break down into root 4 root 3, which is 2 root 3. So then this becomes 4 root 3. So you get the same answer, but you can see that you had to do that whole thing twice. Okay, so if I had something like this, 7 root 18, I'm trying to break down 18, so root 9 and root 2. I can't forget about this coefficient in the front. Then root 9 can become a 3. And I'm just bringing everything down with it, so 21 root 2. Okay, 6 root 98 plus 5 root 18. Okay, so now 98 can become 49 times 2. And 18 is 9 and 2. So 49 is what I would change to a 7. And not root 9 I would change to a 3. So this is 42 root 2's and 15 root 2's. And since they are the same radical, I can put them together to be 57 root 2. Okay, the cubed root of 54. So I don't want to think about those numbers anymore. I want to think about 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed. I want to think about those numbers. So 54 can divide by 27. So the cubed root of 27 times the cubed root of 2, because 2 times 27 is 54. The cubed root of 27 is 3. So you have 3 cubed root 2. Okay, what if I've given you a broken down radical and you have to get it back into a single? So how did you get a 3? It came from root 9. So this would have started with a root 63. Okay, so let's try another one. 8 root 2 to get that to a single radical. So how did you get an 8? Root 64. So this would have started as root 128. 4 root 3, what would it have started with as a single? So that would have came from a root 16 times root 3, which is root 48. 3 root 5, the 3 would have came from a root 9. So this would be root 45. Okay, a couple more. 7 root 3. How did you get that? It came from a root 49 and a root 3, which is the square root of 147. And last is a cubed 2 cubed root 5. So how did you get a 2? You would have had to take the cubed root of 8. So altogether that would be the cubed root of 40.